Thank you for everyone for coming to this next session. We just learned about automating the workplace with Python. Now we're going to learn about automating your home with Sean. Thank you very much.
Thank you. Hi, I'm Sean. Goodness, there's a lot of you. So today I'm going to talk about automating your home with Python, Raspberry Pi, and HomeKit. For those of you who don't know me, my name is Sean. I'm a DevOps engineer for a fintech company. I've been doing automation engineering for the last little while at a couple different places. Gumtree, IAG, the NBN. I'm sorry about that. Automation has really been like a thing in my life. I don't like to do a lot of work. So the main question is, why on earth would anyone want to trust their house to the cloud? For me, my big thing when I came to Australia, I'm originally from Canada. When I left Vancouver, it was -2. I got here in December. I didn't think it would be that bad. It was 44. I spent the first couple of days, just sitting in a corner, sweating and dying, that kind of thing. I thought, all right, we'll get some automation on top of this. We'll figure out like a nice way to do it. That being said, I don't really have that much IoT in my house. Our house is, about 30 years old or so. We have an aircon. It works through infrared. Not really the sort of like automatable thing. So I started taking a look around to see what the options were. I had an iPhone. They had announced HomeKit recently. Seemed like a pretty good pick. So the question is, what is HomeKit? HomeKit is basically a open-ish standard from Apple. They published the specification for HomeKit accessories. HomeKit accessories themselves are typically licensed things, but there is the potential for people like you and me to do our own sort of unauthorized HomeKit accessories. It's really a very Apple-like service in that it is limited to a predefined set of accessories and services. You're not given this kind of like full control that you are with other IoT systems. It's not necessarily as flexible as something like Alexa, but what it does do, it does really well. Sort of really solid implementation. It's got a bit of security built in, and it's got the kind of stuff that you expect as part of like a home automation system. As part of that open spec, there's quite a few open implementations. The biggest one is like a Node JavaScript implementation. On the Python side, there's been a few efforts. The one that I originally touched was called HAP Python, HomeKit's automation protocol Python. When I first started this project a little while ago, that library was super basic. The code required to get everything working was pretty clunky. After the last couple months or so, especially since sort of getting this project up and running and ready for delivery, things have gotten really smooth, to the point where I've got a little bit of code to demonstrate at the end. The amount of code you need to write to get a HomeKit service up and running is almost nothing. So in the HomeKit land, we've got accessories. Accessories are these kind of like common things that you'd have in a house. Your sort of standard things like lights, switches. It even does some fancier things like garage door openers. It's got support for cameras, sensors. These are all exposed as common services inside the HomeKit automation protocol, and that's what we're going to implement in Python with the Python HAP, or sorry, HAP Python. Services are defined by things called characteristics. Characteristics are the sort of attributes of what a service means. For something like a switch, that's basically, is it on, is it off? For something like a thermostat, what's the current temperature? What's the target temperature? There's sort of a split between what characteristics themselves can mean, with the concept very similar to synchronous and asynchronous attributes. A synchronous attribute is something where you set it and that is immediately the case. Something like, I turn my fan on to 100%, boom, that's done. There's no sort of like in between. With a thermostat, there's something, the current temperature and the target temperature. Just because I've set my AC to like 24 degrees, it doesn't mean it's going to be 24 degrees away or right away. There's a sort of build-up period in between that. On the automation side, there's something called the Home app. There's support natively coming to the OS, I think in the next sort of release of OS X. But for the most part, most of this stuff is done through your iOS device or your Apple TV device. These allow sort of like manual and automated control of your devices. One of the really nice things that they offer is sort of a automation based on events. If you really want to get specific with how your automation is set up, you can do things like, hey, when I get home, turn my aircon on. If there's no one left in the house, from some motion sensors, kill the AC, all that kind of fun stuff. By default, if you're just connecting from a device like your local iPhone or your local iPad, that's only available when you're physically in the house. They do offer sort of a remote bridge functionality, but it does require some sort of dedicated hardware. They've given you a couple options for that. The most common one that people have is typically like the Apple TV. So if you've got an Apple TV at home, when you ping a home automation, that's able to handle it for you. The few of you who may have bought that like $600 giant tube speaker, the HomePod, that's also an option. And there's also kind of a neat option where if you've just got an iPad running a relatively recent version of iOS, if that's at home and plugged in, it will gladly operate as a HomeKit bridge. So we've got the mechanisms to kind of invoke these HomeKit protocols. What we need on the other side is something to physically make those things happen. Now, the program from Apple has been around for a long time. There's all sorts of pre-existing products for that. You can even go to IKEA now, spend $30, you get yourself a nice IoT light bulb. Me, I like things sort of like manually controlled. Like I said, I've got an air conditioner already. I don't want to drop another $5,000, whatever, to get like a Wi-Fi enabled one that allows someone from the internet to flick it on and off. So we're really looking for something that we can own and enable. As part of that, the Raspberry Pi. I know there's been a lot of talks today about the micro Python thing. Those implementations are awesome. For me, I'm terrible at that kind of thing. I really want something that kind of works out of the box, something that works for me, and something I can write native Python on. The Raspberry Pi fits a lot of those kind of needs, especially when it comes to the sort of basic electrical automation. One of the nice things you get as part of that Linux ecosystem is a system called LIRC. That's the Linux Infrared something something. That basically is like a super standard set of operating remote controls. It can do IR receiving. It can do IR transmitting. One of the fun things about infrared is that the protocol for turning your TV on and off, that's pretty standard. The protocol for turning your air conditioner on and off or any other kind of appliance, that's up to the manufacturer. There are some commonalities between all of the remotes, but there's a huge range of stuff that can be fired out. Some remotes, every time you push a button, are sending a full stack of state. Some of them are only sending intermittent states. Debugging that sort of thing on lower level hardware is really painful. That's why I really like LIRC. You can kind of troll through GitHub to find other people who have configurations for your remote. That's the one thing that really clicked for me. I spent ages trying to do the manual debugging and reversing of my air conditioner remote control with an Arduino. I had a little IR sensor hooked up to it, trying to capture data, pick it apart. Then eventually, I look on GitHub. Someone with the same AC remote has already dropped in a config, so they've already gone and done the proper debugging of it. I can drop that into my little Raspberry Pi, and then I've got a series of outputs for that. So on that infrared LIRC stuff, out of the box, there's a huge amount of support for infrared transmitters and receivers. If you want to automate something that isn't your air conditioner or is like a TV, all that kind of stuff, that's easy to drop out of the box. And like I said, there's a sort of huge wealth for existing automation configurations. So we've got the means to fire off infrared signals. We've got a protocol for connecting to that. And we've got a home automation control system as part of the little home app. Let's build an accessory. What does that involve? Well, for HAP Python, we have to do a couple things. We have to build something called an accessory driver. An accessory driver is some logic that sits on the little box that says, hey, this is how I connect to the network. The HomeKit automation protocol has a bunch of stuff built into it that is sort of must be this tall to control devices. It handles things for you like security pins, making sure that only authorized people can talk to that service. And it handles all the kind of incoming requests from, say, iCloud if it's coming from a third party. After we do that, we create our accessory. That's basically just defining the accessory itself. That's pretty much taking one of those pre-existing services that we saw before and configuring the characteristics of it. When we set up our characteristics, there's a bunch of work we need to do inside that Python class. Sort of normal setup that you've got for an IoT where you're setting setters, getters. Because you're not using a system that's externally pingable, you have to manage your own state. There's some stuff where we have to consider, what state did we have last, so we're sending the right IR command, making sure that we're always sending the right full set of state. Like I said before, that air conditioner control is sending a full amount of state every time. If I'm trying to update the temperature and I'm firing off a command that switches it to heat, I'm going to have a bad time. And then we need to fire off the driver. This is basically a daemon that lives on the device itself. This will handle the incoming requests from your HomeKit applications. So, that sounds easy enough, right? Air conditioner, it was in the list of services. I can just start going from the get-go. So we take a look here. This is basically a big list of all the services available. There's no air conditioner. What am I supposed to do? Steve Jobs, Johnny Ives, they said it would work, right? I saw it. It's in the list. Now, it's not in the list of actual services. One of the things about HomeKit is because it's the set of robust, well-defined services, when you're creating custom things, sometimes you have to kind of piece these together. Now, because Microsoft is not a sponsor today, we can cut out Windows. So an air conditioner is basically a thermostat control plus a fan, makes an aircon. What we basically need to do is create an accessory that has these two characteristics. For each of these characteristics, we need to make sure that we're setting getters and setters. We need to make sure that we're maintaining the state. And we need to make sure that when our home accessory protocol queries our state, that we're giving back the right state. This gets a little bit tricky, so you need to make sure that whatever's coming in from the home accessory protocol, you are clamping down to whatever makes sense for an air conditioner. Stuff like variable speed controls, which I'll cover in the sort of lessons learned. Variable speed controls don't map to what an air conditioner actually has. Air conditioner, quiet, low, medium, high. Everything that you're getting from the home accessory kit or the protocol is basically a numeric value. You need to clamp down those. These kind of things are only as secure as your iCloud control. If you have home sharing with someone in your family or a spouse at your house, if you give them control to your home automation, they can control it whatever they want. I found this out the hard way. When my son decided he wanted to have a nice try of the new shiny button on the iPad and just spent about half an hour turning the aircon off and on, off and on, while I'm sitting in the living room going like, did I mess something up? In this system, typically no one's going to steal your data. Family might flick your lights on and off. There's also some considerations around the system itself. Siri has some interesting interpretations of what you want. That voice control works with HomeKit, but doesn't always have the exact ability to really guess what you need. There's some options, or sorry, some interesting results that I've gotten out of this. Setting the fan to max. There's no one named Santa Max in your contact list. Set the fan to 25%. I can't do that because I don't know what you mean by Fanta. Some of this stuff is because it doesn't, if you don't maintain the state properly, it doesn't really know what to do. Sometimes it doesn't have the proper consideration for what numbers mean. Like, hey, set the air conditioner to hot. Cool, 1 degree Celsius. I mean, I'm from Canada, but that's still cold. Other times, there's issues where Siri would just give you kind of like a random result. I mean, it's the result that you asked for, but it may not necessarily be what you want. Siri, turn the air conditioner on high. OK, 100 degrees Fahrenheit. So with this kind of stuff, if you temper sort of like what you expect out of Siri, everything else works pretty well. Cool, so let's dig into some code here. The HAP library itself is pretty much like a one-man work of love. It's been getting really good over the last little while. When I cleaned up all this code, came from an earlier version. This stuff, before, it was lines and lines and lines of massive getters and setters. Now it's super clean. So we basically do some basic stuff. We import the PyHap accessories. We grab the category thermostat. We set some basic logging because it's super handy to have that output from HAP while you're kind of debugging. I leave it on as normal because I find just having that log of stuff is really handy. So we do some basic stuff in Python. We declare a class. We're subclassing accessory. So we need to set up a fan service. So we're adding those preloaded services that we saw from that service list before. As part of that, we need to set some characteristics. You don't have to use every single characteristic. If you don't define a characteristic, it won't show up in the UI, which is pretty handy. Fans themselves can have a couple optional characteristics, one of which is rotation speed. The other one is rotation angle. If you're controlling something fancier and you want to be able to kind of swivel left and right, you got that option. If you don't define the characteristic, it doesn't show up in the UI, pretty handy. So we set our rotation speed, configure the characteristic. We do some setter and getter callbacks. And then because we also want to control the temperature in this service, we add a preloaded service of thermostat. Now, for the temperature, you're always configuring and setting the target temperature. Generally, because the invocation for these is expecting like a proper air conditioner with a proper queryable REST API, those generally have like thermostats built in. They can give feedback to it. Because we're just firing off IR signals, we don't have that ability. If we wanted, you pop onto any little part ordering site, you can get a little thermostat reader for the Raspberry Pi. It's about $5, works pretty well. Yeah, so we're going to always set that current temperature to whatever the target temperature was. We've got some actions here where we're toggling the power. I've got a little sort of wrapper library that I did for the aircon just to abstract out the aircon stuff. If you've ever used LIRC before, LIRC has some command line options where you basically just fire off a command. The people who generate your configs, because you're not generating your IR codes on the fly, they basically just give you a giant mapping of like, hot on 20 degrees, cool, low 10 degrees, all that kind of fun stuff. So we basically just wrap around the command line invocation of IR send, and off we go. You can see here the get power, we need to return that state. Temperature, characteristics have the option to notify. Notification means it'll fire the notification that characteristic is updated back into the protocol. So for fan speed, this is what I was talking about with clamping. Because you're receiving raw values, you're always going to have to clamp these down to something acceptable. Here, we have a simple if statement switch. Clamp it down to whatever you want, and then return the speed. Here's the driver in it. Like I said, this stuff is super basic. This is a functioning service almost out of the gate. We attach the accessory driver to the driver, driver add the accessory. We also give it a couple signals. The HAP, the protocol, has some niceties around it where it will monitor the status of your services, so they're always being pinged. When your services disconnect, it wants to know about it. Adding these little handlers when you sig kill it just means it'll fire off a little message to say like, hey, aircon's not there anymore. Then we start the driver. Let's touch the aircon stuff. So the aircon is just super basic. We're doing a sub-process, check output. If you want to get fancier, there are LIRC libraries for Python. I wanted something that would just fire off commands because I wasn't doing anything special, so there you go. Cool, so that's kind of like a little walkthrough of the code itself. Let's see if we can do a demo. Now the way this is working, it's not great. The mirroring for the iOS is over a network cable, which disables tethering, which means I have to tether also with Bluetooth because this requires network connectivity to work. This should work. If not, no one else's demo has failed today. Maybe I'm the first. We've got a little environment variable just to mock IR send. This is for our testing. So it goes and fires up the system, gives you a super nice QR code. Oh, it's a little bit too big. Cool. So we pick up our home connected device, add an accessory, point it at this one. Uncertified accessory. Real HomeKit products have a license from Apple. You gotta pay them $1 billion. We don't need to do that. We just add a uncertified accessory. There's no real security problem with this as long as you have the pin covered up when you're doing it. That pin is your security initialization between the two. The HAP Python will save a state of that pairing into a little file called accessory.state. So every time you boot up, it will remember that state, and you only have to do this pairing just once. Boom, so we add it. So we should start to see the pair verification here. You get a little verification on the iOS service that says, like, hey, identify these accessories. This is part of the system with HAP where you can kind of fire off commands to your IoT stuff to identify them. Super handy if you've got multiple items. When I was taking a look at the automated light bulb, I just made it flicker whenever I hit identify. Identify, you'll see little requests come up for those identification requests. Because we've created two services, both those services will come up. You'll see here we've got the default room air conditioner. Cool. So now we've got two services available to us in the Home app. There's some options we can do for that here. All sorts of things that we can kind of set up. So as you can see, we get a rotation speed gradient from 24 up to 63. You need to clamp down on those. I just kind of let it slide, and my air conditioner beeps like 5 or 6 times. If I had some more time, I'd probably just make it wait a little bit. All the details are available for here. We've additionally got the temperature settings here. Fire up the temperature, control all our modes. We've also got additional optional Siri integration. Like I said before, the Siri integration, sometimes it's great, sometimes it's not so great. Let's give it a shot. Hey, Siri.
Good afternoon, Teddy.
Oh, sorry, my son is named Teddy, and he's changed my name. All right. Siri, can you turn the air conditioner off?
Okay, the air conditioner is off.
Cool. So we've received the notification here in our HAP protocol. The air conditioner has turned off. We get a bunch of kind of pre-loaded actions with these. So as long as Siri can kind of guesstimate what you're after, you get pretty decent control with these. You've also got control through the Home app on the Apple TV if you're going. Other than that, it's a pretty standard and easy way to get your devices up and running and automated. All you need to start is just an iOS device. Cool. Demo. Oh, I think I run a little bit quick today. Cool. If you're interested in getting involved with this, it's an open source project. HAP Python, made pretty much by a single gentleman named Ivan. This library has come a long way in the last little bit. If you want to do any kind of open source contribution for it, now's the perfect time to get involved. There's some definitions of the HomeKit accessory protocol that can help sometimes when you're doing debugging. That's more on the network wire level. LIRC is a bit of a pain to get set up on the default Raspbian distributions. So I've got in these slides, which I'll upload later, there's a little link to the sort of gist that'll help you get everything up and running. I think that's everything for me. Thank you very much.
Thank you very much, Sean. We've still got about 5 minutes of time. So if you've got any questions, we can fit them in. Any questions from anyone?
The traditional problem with IR protocols is it's unidirectional. So if you send sort of one incorrect bit and get out of sync with your AC unit, you're just dead. Do you meet that problem here? Do you ever encounter that, or is that solved because every packet is complete state?
Every packet is complete state, and there's a little bit of stuff on the end that does the sort of like internal validation, similar to like a kind of CRC check. That will depend based on your model of AC. Like I said before, there's no real standard for air conditioner units, so that really does vary. But we do generally get full packets out. As long as it's being driven through the LRC, I found that everything is pretty solid. I did have a lot of issues when I was doing the kind of like low-level bit banging with Arduino stuff, and that was one of the big drivers for me getting over. That I found was a lot more difficult in the receiving part. Sending tends to be pretty simple. An IR LED with a normal resistor has a pretty decent range in a house. I keep mine up on a shelf about a foot away from the air conditioner, so it doesn't really need to go too far. That being said, I've had it work from about 5 meters away before. That stuff's pretty solid. Normal IR stuff applies, so like direct sunlight will mess it up. Kids pulling it apart will mess it up.
Do you have any more questions? No? All right, thank you very much, Sean. Please give him a round of applause.